In this video, we're going to talk about the intersection and union of sets. Okay, so starting with the intersection of sets. The intersection of sets A and B is the set of all elements that are common to both sets A and B. So that means these are the elements that are contained in both A and that are contained in both set B. And we use the notation, it looks like an upside down U to represent intersection. So this is the notation for intersection. And the formal definition is it's the set of all X such that X is an element of A and X is an element of B. All right, so that is the intersection of sets. All righty. Now, the other definition is the union of sets. So the union of two sets, A and B, is the set of all elements that are in A, in B, or in both A and B. Okay, so union, which when you think of union, you think of like people coming together, forming something. So you think of taking all the elements that exist in the sets that you're talking about and combine them together into one set. And so for A union B, we use the notation A U B. It looks like a capital U that represents A union B. And the formal definition is it is the set of all X such that X is in A or X is in B. So basically we take all of the elements in A and all the elements in B and we list them out. And then if there is something that's in both A and B, excuse me, we only list it once, okay? So let's look at some examples. For this first example, we want to find the following. So we have two different parts. So for part A, we have this set with 7, 8, 9, 10, and 11 in it. And we want to find the intersection of that set with this set that has 6, 8, 10, and 12 in it. So remember, intersection is what the two sets have in common. So I'm looking for something that's in both this set and in this set. And so 7 isn't in this set. 8 is in both of those sets. This one has 6, but this one doesn't. 9 isn't in this set. 10, they both have 10. This one has 11, but this one don't. This one have 12, but this one don't. So the intersection for part A would be the set with 8 and 10 in it. That would be the intersection for part A. Okay? And then for part B, we want to do something similar, but we have two different sets. The first set has 1, 3, 5, 7, and 9 in it. And the second set has 2, 4, 6, and 8 in it. So I'm looking for the intersection of those two sets, meaning what do those two sets share? And so this one has 1, but this one don't. This one has 3, but this one don't. This one has 5. That one doesn't. This one has 7. That one doesn't. 9, but this one don't. So it looks like this one has all odd numbers. This one has all even numbers, which means they have nothing in common. And so remember what the set is with nothing in it. It is called the empty set. So the intersection of those two sets will be the empty set because they have no two things in common. Alrighty. And so that's how you will work this example. Let's look at another one. For example 2, I have the same exact sets that I had in the last example, example 1, except the only thing is we changed the intersections to unions, okay? So we still want to find the following. This time I want to find the union of the set with 7, 8, 9, 10, and 11, and the set with 6, 8, 10, and 12. And so union means you take everything from both sets and you put them all together. So for A, the union would be, and we typically like to list them in order if they're numbers. So 6 is the smallest. So we have 6, 7, 8, 9, 10, 11, and then this set also has 12. So for the union of those two sets, you take all of the sets and you list them out. And although they have 8 and 10 in common, which we know from the last example, you don't have to list 8 and 10 twice. You only list those once. So notice I only have 8 and 10 listed once, okay? And I've written them in order. So I want to do the same thing with part B. I have 1, 3, 5, 7, and 9, 2, 4, 6, and 8. I want to take everything in both sets and combine them together, and I'm going to write them in order. So I'm going to get 1, 2, 3, 4, 5, 6, 7, 8, and 9. And basically that's the union of those two sets. You take everything that's in both sets and you combine them together. So that is how you will find the union. And the last example that we looked at is how you will find the intersection of two sets. Anytime you have the empty set and you want to empty set a set and empty set a set, anytime you want to intersect a set with the empty set. So you taking a set with some stuff in it, regardless what is in it, and then you have a set with nothing in it, and you want to see what do those two sets have in common. Well, if you have a set with nothing in it and a set with whatever's in it, they're not gonna have anything in common because of that empty set. It has nothing in it. So anytime you take the empty set and you intersect it with the set, you'll always get the empty set. Okay. All right. Now, what about union? So now think about this. You got a set with, it could have whatever in it, and you want to union it with the empty set, which is a set with nothing in it. Remember, union means you take everything from both sets and you put them together. Well, if you take everything that's in A and you put it together with this set that has nothing in it, then you're going to end up with just the elements from A. So anytime you union the empty set with another set, you'll always get the set that you're unioning it with. That was hard to say. Unioning it with. Okay. All right. So this is anytime you have the intersection or union of the empty set. For example 3, I want to find the following. So this first set, or this first example, part A, I have the set with 1, 2, and 3 in it, and I want to union that with the empty set. So remember, if I take a set with nothing in it and I union it with another set, I'll always get the elements that are in that other set. So this will just be equal to the set with 1, 2, and 3 in it. Okay. For part B, I want to take the set with 1, 3, 5, 7, 9, and I want to intersect it with the empty set. So that means, what do they have in common? Well, since this has nothing in it, that means they have nothing in common. So that would be the empty set. And so that's how you would do this example. So we can also do what we call performance set operations, which is we perform some different operations on sets. And in this example, example 4, I have an example of where you can perform set operations. So we have this universal set that has numbers 1 through 10, all the natural numbers 1 through 10. Then we have A that has 1, 3, 7, and 9. And we have the set B that has 3, 7, 8, and 10. And we want to do 2 different things. So we're going to perform 2 different sets of operations on these sets. So the first thing we want to do is we want to find the complement. Remember, this little line outside means the complement of A union B. So in order to find the complement of it, we first have to find what A union B is. Okay. So A union B means you want to take everything in A and everything in B and put them together. So A has 1, 3, 7, and 9, and B has 3, 7, 8, and 10. So if I put them all together, I get 1, 3, 7, 8, 9, and 10. 1, 3, 7, 8, 9, and 10. So that would be the union of A and B. So now I want to know, what is the complement of A union B? So remember, the complement is everything that's in the universal set that's not in that set. So A union B has 1, 3, 7, 8, 9, and 10. So the complement of that would be everything that's in this universal set that's not in that set. So 1 is in there. So 2 would be in the complement. 4 would also be in the complement. 5 would be in the complement, and 6 would be in the complement. Then you have 7, 8, 9, and 10. So the complement of A union B would be the set with 2, 4, 5, and 6 in it, because those are the elements that are in U but are not in this set A union B. Okay, so that's how you will perform the operations for that first part. Now for the second part, part B, we want to find A complement intersection with B complement. So first thing we need to do is figure out what is A complement. So A complement is all the things that are in U that are not in A. So A has 1, but it don't have 2. A don't have 4. A don't have 5. A don't have 6. It has 7. It don't have 8. It has 9, but it don't have 10. So A complement would be the set with 2, 4, 5, 6, 8, and 10. Alrighty. And then we need to figure out, what is B complement? Well, B complement is all the things that are in the universal set that are not in B. So B has 3, but it don't have 1. It don't have 2. It don't have 4. It don't have 5. It don't have 6. It has 7 and 8, and it don't have 9. And that's my little brace that's looking weird. Okay, so B complement, that's a line right here for B complement, has 1, 2, 4, 5, 6, and 9 in it. That's all the things that are in U that are not in B. And so now I want to figure out, what is the intersection of those two sets. So what is A complement intersect B complement? So I'm looking at, what do these two sets have in common? They have the 2 in common, the 4 in common, the 5 in common, and the 6 in common, and that's it. So it would be 2, 4, 5, and 6. And you get the same exact answer as we got in the last problem, okay? And so that's how you would perform those operations. So you have to take it and break it down piece by piece and then put the big picture together. All right. Now, if you have any comments or questions about that, please don't hesitate to email me. Okay. Now, I want you to take a moment to try an example and see if you can get it right. All right. So just pause the video. Well, hold on. Let me read it to you first. So I want you to try this. You have the universal set, which is A, B, C, D, and E. You have A that has B and C in it, and you have B that has B, C, and E in it, and you have to find A complement intersect B complement. So now pause the video for a moment and see if you can get the answer. Okay, so did you get this, the set with A and D in it? If you got that, then good job. You can keep on going because you're on the right path. All right, so I'm just going to walk you quickly through how you get that. So A complement would be the set with A, D, and E in it. And then B complement would be the set with just A and D in it. And so what do those two sets have in common? They have the A and the D in common. Alrighty. The last thing we're going to talk about in this video is the cardinal number of the union of two finite sets. Okay, so that means, remember, cardinality is the number of elements in a set. So if I want to take the cardinality of A union B, and A and B both have to be finite sets, then there's a formula that will help me calculate that. And the formula looks like this. It's the number in A plus the number in B minus the number in both A and B. So the number of the A intersection B. All right, so this means I want to add all the things that are in A and all the things that are in B, and then I want to subtract the number of things that are in the intersection of A and B. And that's because those elements are counted twice. When A and B have things in common, then those elements will be counted here in A and they will be counted here in B. And so you have to subtract those out once so that they won't be counted twice. So that's how you find the number of elements in A union B. And so let's look at an example on how that plays out. For our last example, we have, according to factomonster.com, according to the number of presidents in the White House, 26 of them had dogs, 11 of them had cats, and 9 of them had both. Okay, we want to figure out how many presidents had cats or dogs or cats. However, I think I said it backwards, but dogs or cats. Alrighty. So if we let A represent the number of presidents that had dogs, then that would be our 26. So A is dogs, and if we let B represent the number of cats, that would be our 11. So B is cats. And then it said that 9 had both. So that would be our A intersect B. That would be 9. And we want to know how many had dogs or cats. Now, I don't know if you noticed earlier, but in the formal definition of union, it had the word or in it. And then in the formal definition of intersection, it had the word and in it. So or refers to union and refers to intersection. So since it wants to know the number that had dogs or cats, then we're looking for the number of the union of those two sets. And so we can use that formula that we just previously talked about, the number of the union of two finite sets, which we know those sets are finite because they have numbers attached to them. All right, so that would be the number in A plus the number in B minus the number in A intersect B. So that would be our 26 plus 11 minus 9. 26 plus 11 is 37. 37 minus 9 is 28. So that means 28 presidents had dogs or cats. That's how you would calculate that. All right, and it's a common error to just add them all up. But remember, when you add the 26 and 11, to add the 26 and 11 together, but when you add the 26 and 11, you end up counting some of the presidents twice because they had both a cat and a dog. So you have to remove the ones that had both because they're counted twice in that original, just adding the two. So 28 would be your answer. And so that's how you would calculate the number of elements in the union of two sets. If you have any questions about this, any whatsoever, please don't hesitate to put them in the comments or to email me. I will respond as soon as I get a notification, okay? And if you haven't already, make sure you hit the subscribe button. And if not, I'll just see you in the next video. Thanks for watching.